Okay, 8.3 is normal sampling and modeling. So if a population of a set of data, if we believe it to be normal, and therefore of course, when we talk about normal, we talk about a distribution, a probability distribution taking on that bell shape, then predictions can be made from a sample taken from the population. Okay, so we're going to talk about samples in this case. So Mickey Mantle played for the New York Yankees. The number of home runs he hit each year are listed below. So if you count these, the number of data that we have is 12. And from this right here, we talk about sample. Okay, so determine the mean and standard deviation of these data. So the mean, we're going to use, instead of using a mu, we're going to use x bar, because we're going to take this as a sample of every single season played by every single person. Okay, so if we add up all these, so 24 plus 33 plus 36 plus 27, so on, what we're going to do is we're going to get 384, and then we're going to divide that by 12 and get the answer of 32. Okay, so the average, or the mean, x bar equals 32. Now, let's just recall the standard deviation. So for a sample, standard deviation, we use an S instead of a sigma. And we're going to add up the sum of the x values, which are these values independently. We're going to subtract x bar, square it, all over n minus 1. Okay, so n minus 1, that's a little bit different because we're used to using the population. We use the population very often. Now we're going to use n minus 1, which is going to account for the error. Okay, so let's go through these. And just to recap, these numbers here, there are many of these numbers that are listed more than once. So what we're going to do is just like multiply by the frequency. So let's make that chart. We have x, we have a 24, and then what we're going to do is we're going to go x minus x bar, and we're going to skip all these steps, and we're just going to square it right away. And then what we're going to do is we're going to list the frequency, and then we're going to multiply the frequency by x minus x bar squared. Okay, but we can leave all of these in our calculators at the same time. So 24, we have one value that's a 24. We have 1, 2, 3 27s. We have 1, 2, 3, 4, 5 33s. We have 2 36s and a 42. We have 36, 42, 2 and 1. Okay, so now let's actually calculate. So 24 minus our average of 32 is -8, and then we square it is 64. So 64 times 1, again, just 64. 27 minus the 32, which is the average, is -5, and we square it, which is 25. Multiply that 3 times, because we have 3 of those values, we get 75. 33 minus 1, or sorry, 33 minus this 32 is 1. Square that, we have 1 times 5. Okay, 36 minus the 32 is 4. Square it, we get 16. So 16 and 16 is 32. And then 42 minus 32, which is 10. We square that, we get 100. 100 times 1 is 100. That was a very, very nice set of data. So now what we want to do is add them all up, and we get 276. So this addition sign right here, we get 276, and then we're going to divide it by 12 minus 1. I get the answer of 25. Let's just round it. I get 2509. So let's just round it. Okay, so now we have the mean and the standard deviation. So we're done A, and we had to manually do that. We had to pull out information from about like 2 units ago, and that's fine. Now, we're going to assume that this distribution is normally distributed, okay? So what we want to do is, again, I usually draw this every single time. Okay, the mean in the middle is going to be 32. We want to know what the probability is that he hits more than 32 home runs in the season. Well, that's easy. 32 is right in the middle. Okay, it's the mean. So over here is going to account for 50%. And we know that just because the bell curve is symmetric. So we had 50% on the left-hand side and 50% on the right-hand side. Now, what about less than 28? So let's change my color here. So let's say that this here is 28, okay? Oh, I'm so sorry. This, I'm gonna put in blue. Sorry, we had to root this. So root 25, I'm sorry, standard deviation is actually just 5. The variance was 25. Okay, so it doesn't change I, but it will definitely change number 2 here. So less than 28 home runs. We're looking for this red portion. So let's write in red so that they just match up. So let's go z-score equals x minus x bar over sigma. Okay, the z-score is going to be 28 minus 32 over 5. So 28 minus 32 is -4 divided by 5 is -0.8. That is our z-score. So let's take a look at the z-score table. Okay, -0.8, so we're going to go to the negative side, 0.8, and then it's just 0.80. So I get 0.2119. So going back to here, we get a probability. So we'll write the probability that x is less than 28 equals 21.1, I believe we said 9%. Okay, now if Mantley plays 5 more seasons, how many home runs would we expect him to hit? So this has to do with expectation. So expected, he's going to hit, we expect him to hit the average, right? The 32 each season. And he's going to play for 5 more seasons. I'm going to go with 160 more home runs we expect him to hit.